Welcome back, students. We're doing lesson 5, adaptive defense. So the objectives are similar to the last time. We're still talking about white blood cells, antibodies. We're going to talk about major cellular and chemical components, and we'll talk about how the body attacks foreign and abnormal substances like proteins. Okay, so the last time we talked about the innate defenses like skin, mucus, neutrophils, macrophages, natural killer cells. Okay, if that system gets overwhelmed, we have a second backup system, the adaptive system. And the adaptive system really means just that. It can adapt and adjust and change and remember. It's actually so cool. It's very amazing. Okay, next. Okay, so as we get into the adaptive system, we need to know what a B lymphocyte is, an antigen, and an antibody. Antigens, antibodies, okay? So remember, a macrophage will swallow a pathogen, kill it, spit it out, and then something happens that I didn't tell you before. And it then displays the body parts called antigens on its surface. So imagine taking in an invader, ripping it up, and then putting its body parts on, like imagine wearing its body parts. Okay, that's really that's really what happens here. Okay, and then there's a complex sequence of events happens, and the B lymphocytes can create these things, these proteins called antibodies. And they're designed to specifically attack those dead body parts. Okay? So what does this look like? Well, let's say here's a virus. Let's say that's a flu virus. Here's our macrophage. Okay? We detect it. We pull it in. It's now inside of our white blood cell. We kill it. And then before we spit it out, we rip off its body parts and display them on our surface. We wear them like jewelry. Okay, so there we go. Now those dead body parts are called antigens. I wish they weren't called that. It's not an exciting name, but they're called antigens. Okay, dead body parts. Now a B lymphocyte creates matches for those dead body parts. It starts creating proteins called antibodies. And those antibodies are, there's thousands of them, and they're designed to specifically attack the dead body parts that are its match. So these antibodies are an exact match for those antigens or dead body parts. And the next time an invader comes in, the same type of virus, the flu virus that came in before, this B lymphocyte is now an exact match for the flu. Okay? That dead body part matches up with body parts on the same type of virus coming in, and those antibodies are designed to specifically fight those exact proteins, those dead body parts. Okay? All right, it recognizes the body parts, attack. Okay. So let's imagine, so I've kind of already said this, but let's just review and just say it again. Imagine that a virus enters the body. That virus, that pathogen, has a marker on its surface. That marker is called an antigen, okay? It looks like the dead body parts that we recognize from before. When a B lymphocyte encounters the pathogen with those same types of body parts, the B cell recognizes the invaders and those antigens. I've seen body parts like yours before. Now, B lymphocytes have like 10,000 antibodies on their surface. There's lots. Okay? I don't know if you watch The Office. You know when Michael Scott encounters Toby Flanderson, Michael gets triggered? I think of it the same way. When a B lymphocyte meets its antigens, it's like Michael meeting Toby. and it just ticks him off. Okay? And when he gets ticked off, the B lymphocyte clones itself and then turns into two types of cells, effector cells and memory cells. Okay? So watch this. So there's our B lymphocyte. Virus comes in. It recognizes, I've seen body parts like yours before. In fact, I'm an exact match to fight you and your body parts. Trigger, Flanderson, Michael Scott. And then I'll eat you up, but now I'm going to clone myself. And I'm going to clone a bunch of memory cells so that we can remember you. And I'm going to create a bunch of warriors to fight you. Okay? So the memory cells will remember that type of virus forever. And the effector cells will fight that type of virus forever. Then these clones begin mass producing antibodies. And this is an astonishing statistic here. 2,000 antibodies per second for a few days. Okay? Now, these antibodies bind to antigens. So it's terminology, right? But the antibodies link up to the dead body parts, or to the what looks like the same type of body parts. Okay? And then they mark them for destruction. Now, antibodies are not the killers, but they basically raise flags that tell the soldiers to come in. Okay? And what the antibodies do is they block binding sites, or they can like start binding to a bunch of different viruses at the same time and create clumps. Okay? And these clumps slow down, they're easier to catch. And then the phagocytes come in, the neutrophils or the macrophages, and they come in and do the killing. Okay? All right, so what does this look like? So there's our effector cell. It's been cloned. It's one of the clones. Its effector means it's a warrior. Okay? Viruses attack. Now, this is not a great way to show this, but I'll just do this for a sec. Inside the B lymphocyte, or the effector cell, there's a nucleus. Surrounding the nucleus is the endoplasmic reticulum. That is where proteins are made. So little antibodies start shooting out of here. 2,000 per second. They're just flying out of here, right? Okay, so that's what you got to imagine. So in the bloodstream, there's all these little antibodies floating around. And they recognize certain viruses, and then they attach themselves. Okay, so I'm going to clean that off. Now, I didn't make my animation quite that exact, but here's basically what happens. So antibodies recognize that exact invader, and you can see what I am trying to show here is that all of these little antibodies have blocked binding sites that viruses use to attack our body's healthy cells. To attack our body's healthy cells. Also, we can link these together, and they create this clump, and they're easier to spot. Okay? Anyway. And then this is what happens. And then the killers come in and kill them. And so that's how your body works. Isn't that cool? That's so cool. Okay. Now, every B lymphocyte has its own unique antibodies, which means each soldier is designed to fight a specific invader that has antigens on it. So, for example, B lymphocyte 1 in your body, now that's not a name, like we don't have one called B lymphocyte 1, that's just me designating a lymphocyte, is designed for the flu virus. Maybe the next one's designed for the cold virus. The next one is designed for chicken pox. Okay? So I'll just clean that off. So maybe that's the flu virus. And what I'm trying to show on here is basically green virus matches up with green antibodies. Okay, look at the next one. Orange virus, orange antibodies. Now, I actually don't like that picture of that virus because that actually looks like a bacterium, not a virus. But anyway, I'm not worried about that. Just the idea that that invader, that pathogen, is matched with those antibodies. Okay, and pink invader, pink antibodies. So each B lymphocyte is designed to kill a specific invader. And that's the cool thing. Your body can adapt. New invader comes in, you get sick for a while, and then you get over it, and now your body can fight that invader. It didn't know that invader before, but now it knows it, remembers it. That is so cool that your body can do that. How can your body do that? That's a miracle. Okay, and let's talk about vaccines. What is a vaccine? A vaccine is just a dead or a very weak virus that's on purpose injected into your body. So why in the world would we do that? Well, we would do that because your body would then encounter the virus, see it for the first time, rip it up, display its body parts on its surface, and then go through that whole process I just showed you, remember those dead body parts. The next time somebody else with similar body parts enters your system, you can then clone yourself, make antibodies, remember the bad guys, and then attack them. Okay? Like, how cool is that? We can like artificially introduce weak viruses, and then your body can adapt and then fight those viruses in the future. That is so cool. And that's what we're trying to do with coronavirus right now. We're trying to develop a vaccine. So scientists are trying to get a vaccine, a weak virus or a dead virus, and then introduce it into your body and my body. My body and your body will rip up that virus, display its body parts, remember those body parts. The next time that virus enters our system, our body can now fight it. Isn't that cool? That is cool. All right, so anyway, that's it. You got an assignment to do. Have fun with it. Enjoy.